Hello and welcome once again. Let us move to the further question paper solution of GTU, that is Gujarat Technological University, of first year engineering physics. I am Hardik Maru and we will move forward to get the solutions for the questions which are asked, or if I say the questions which are repeatedly, or some of the questions which are newly asked in your question paper. We will also solve that question. Let us go towards the mostly asked first question according to our slide. Let us see that. A hall has a volume of 12,500 meter cube and reverberation time of 1.5 second. If 200 cushion chairs are additionally placed in the hall, what will be the new reverberation time of the hall? The absorption of each chair is 1 OWU. So this is the question. According to me, this is the question, or this is the numerical which is asked frequently. We will calculate the reverberation time which is asked due to the absorption of sound energy. We will also see which type of equations are frequently asked. Let us move to calculate this sum. For that, we need a calculating paper. According to our question, a hall has a volume V. Here V represents the volume, and the value of volume is 12,500 meter cube. This is the value of volume. The reverberation time in this equation, or in this question, the reverberation time is represented by T and the value is 1.5 second. If 200 cushioned chairs, that means 200 extra chairs will absorb more amount of sound. What will be the new reverberation time? Friends, we have given one reverberation time which is represented as T1, and we have to calculate the another reverberation time in second. So we should calculate this T2. The absorption of each chair, my dear friends, there are 200 chairs, and absorption of each chair, if I say A or A bar, it will be 1 OWU. The absorption of each chair is A, that is 1 OWU, that is open window unit. To calculate that, we have one equation. I am writing that equation. T is equal to 0.167 into V upon summation of A into S. Here T represents the reverberation time into V, that is volume, summation into A. A represents the value of absorption coefficient, and S represents the surface area of any particular surface. To calculate it furthermore, we will calculate it in this manner. Here summation of AS represents total absorption, It is total absorption. We will calculate it that T is equal to 0.167 into V upon summation of AS. The value of T is 1.5 second. The value of V is 12,500, which is divided by summation of AS. We don't have the value of summation of AS, which is total absorption. So we have to calculate summation of AS. Summation of AS is equal to 0.167 into 12,500, which is divided by 1.5. By calculating this equation, we will get the value of total absorption. The unit to measure total absorption is A, that is absorption coefficient Sabine. The unit to measure absorption coefficient is Sabine multiplied by the surface area, that is meter square. So the unit to measure summation of AS is Sabine meter square. Now we should find out T2, that is the new reverberation time, and T2 will be equal to 0.167 multiplied by V, that is 12,500 divided by summation of AS plus A1S1. Question will be, what is A1S1? A1S1 is the extra 200 chairs which is additionally kept. When extra chairs are kept, what will happen? They will absorb the extra sound. That means more absorption will be there in case when additional things are added. Additional things are chairs here, 200 chairs. So friends, we can get summation of AS from the above equation. We will substitute that value here, but we need to find this A1S1. Let us calculate that A1S1. Here we can calculate, think that it is summation A1S1. We have to calculate it by A_S1 plus A_S2 plus up to plus AN_SN. Here S1, S2 up to Sn and A1, this all A represents the absorption coefficient and S1, S2 represents the surface area of each chair. We don't have any surface area, so we will consider it as 1 multiplied by the absorption coefficient of each chair will be 1 plus 1 multiplied by 1 plus up to plus. Here AN will become A200 S200. That means you have to add 1 by 200 times and you will get the answer A1 S1 will be equal to 200 Sabine into meter square. So our next step will be T2 is equal to 0.167 multiplied by 12,500 divided by the value of summation of AS plus 200. After substituting the value of summation of AS, you can calculate T2 and T2 will be your new reverberation time. In our next slide, we will see the answers of this question. Let us move towards the slide. Here, my dear friends, summation of AS is total absorption. The value of total absorption is 1391.66 Sabine into meter square. The value of reverberation time by substituting the above equation or above values in T2 or the equation of T2, we can calculate the new reverberation time. Why we supposed to calculate new reverberation time? This is most question. Because there was a particular reverberation time 1.5 when there was a particular absorption of summation of AS. We calculated the value 1391.66 Sabine into meter square, which was during the reverberation time T is equal to 1.5 second. But what happened is, when 200 chairs were additionally placed, the absorption increased. That means in the denominator the absorption get added more, and due to that more absorption, reverberation time decreased. That means what? Reverberation time and absorption are inversely proportional to each other. Let me show you on that board again. T is equal to 0.167 into V upon summation of AS. This is total absorption and this is reverberation time. If reverberation time is increasing, summation of AS is increasing, reverberation time decreases. In the same manner, if reverberation time increases, or to increase the reverberation time, we should decrease the total absorption. And summation of AS represents the total absorption. So, if we add another absorption, what will happen? That the absorption in the denominator will increase. And through that, if this is increasing, the reverberation time will definitely decrease. So, let us move towards our slide. Here you can see that the new reverberation time is 1.3115 second. What does it represent? The first reverberation time was 1.5, but the second reverberation time decreased and it became 1.3115 seconds. That means what? When sound absorption increases, reverberation time will definitely decrease. So, to control reverberation time at a particular value, we should increase or decrease absorption as necessary. And if absorption increases, reverberation time will definitely decrease. Let us move towards next question. Write a short note on the following. There are two notes or there are 2 points on which we should explain. The first point is isotopic effect and the second point is Meissner effect. Let us first of all see the isotopic effect. The critical temperature, or as I say, transition temperature, which is represented by Tc. The critical temperature value of a superconductor is found to vary with its isotopic mass. This variation in critical temperature with its isotopic mass is equal to the isotopic effect. That means what? What does isotopic effect increases? This is the recent work where when superconductivity was found out, the critical temperature was very low. The value of critical temperature for mercury was 4.2 Kelvin. That means 4.2 Kelvin is a very low temperature. To achieve 4.2 Kelvin temperature in normal conditions is not easier. So, if we want to get the superconductor in normal condition, we should increase or we need to increase the critical temperature. As per the equation, you can see here in the equation that Tc is proportional to 1 upon under root m. Here m represents the isotopic mass. When or which is inversely proportional to critical temperature. A critical temperature is inversely proportional to the square root of isotopic mass, which shows us the relation that when isotopic mass is decreased, the critical temperature can be increased. That means you are preparing or when you are making a superconductor, if the isotopic mass is decreased, you can increase the critical temperature of that superconducting material. So, this is the isotopic effect. That means what? By changing the values of isotopic mass, you can change the values of critical temperature. So, by changing this isotopic values or isotopic values of mass or isotopic mass values, I beg my pardon, isotopic mass values, you can get the values of critical temperature as per your need. Let us move to next point, that is Meissner effect. The complete expulsion of all the magnetic field by a superconducting material is called the Meissner effect. The complete expulsion, I repeat, the complete expulsion of all the magnetic field by a superconducting material is called the Meissner effect. That means what? The complete expulsions means what? When